we have given in this example a piecewise defined function. As you can see over here, we have given some rules, right? So when x is less than 1, then the function is defined by x. But if x is exactly equal to 1, then the function is just defined by 4. And when the x value is, let's say, or if you choose any real number which is greater than 1 and less than or equal to 2, then the function is defined at that for that number by 2 minus x square. And when x is greater than 2, then the function is defined by x minus 3. So we have a set of rules here depending on what type of real number you choose, right? So this type of function is known as piecewise defined function. What we need to do here is find the following if it exists. So we need to find the limit of the function, this piecewise defined function f, when x gets closer and closer to 1 from the left side. We also need to find the limit of the function f of x when x gets closer and closer to 1 from the right side. We need to find the limit of the function at 1. We need to find what is the value of the function at 1, and then so on. So let's try to work on this problem. But before we even begin, I generally encourage students to summarize the information that we have on the piecewise defined function on a real line. How can we do that for the piecewise defined function? So let's try to see here. So let's draw a real line here, okay? Let's draw a real line extended towards negative infinity to positive infinity. Okay, and let's try to see on this piecewise defined function and then see what are the partition number here that where the rules are, let's say, break from one to another. Okay, you can see here when x is less than 1, then we have x. So you can consider that like a kind of a partition number. So let's have that number over here. Okay, and then there is another number here. It's given when x is greater than 1 and less than or equal to 2. Then we have a different rule. So let's have those numbers, so 1 and 2. Okay, so once you write down those partition number here, let's try to summarize this information, and then let's try to see. You can see here are 3 different sub intervals from negative infinity to 1, 1 to 2, and then 2 to infinity. We just try to see how the rule is defined on that location. Okay, so that's what we'll try to do. So let's try to do that. Sorry. Okay. Okay, so you can see that read the first line given over here. Let me first erase all of these things over here, and then so when x is less than 1, then the function is defined by x, right? So that means if you choose any real number which is less than 1, right, less than 1, then the function f is defined as just x. So if you choose any real number over here, you are just going to find the value of the function by that rule, just x, right? We use that. By the second set of rule, you can see here it's given that if x equal to 1, then the function is defined just as 4. So that means the value of the function exactly at 1 is actually just 4, right? So that's what we have given. And then if you read the next line over here, when you choose a real number which is greater than 1, okay, let's have the parenthesis for that, and less than or equal to 2, let me have a bracket for that, then the function is defined by 2 minus x square. I'm just trying to kind of copying whatever rule we have given. I like to visualize this kind of summary on the real line, so it will be very helpful later on to evaluate the limit. Okay, so that's what I'm trying to do. So you can see when x is greater than 2, then the function is defined by x minus 3. So if it is greater than 2, so since it is not equal, so I was using parentheses on the other side, so x minus 3. So this is how the function is given. Okay, I'm not working right now up to this point. I'm not solving the problem. I'm just trying to kind of summarize the information that is given on the function, or I'm trying to understand how the piecewise function look like here, right? Okay, now let's try to work on this first problem here then. So we need to find out what is the limit of the function when x gets closer and closer to 1 from the left side. So let's try to find that. So our goal is to find the limit of the function when x gets closer and closer to 1 from the left side. Okay, so if you remember the definition, so how can we do this? What we just need to do is go closer and closer to 1 from the left side, and then that's the direction we will be moving, right? So going closer and closer to 1 from the left side. So whenever we go closer and closer to 1 from the left side, right, you can see that means when the x value gets closer and closer to 1 from the left side, the y values always, actually you can see on these, no matter wherever you are, whatever real number you are choosing, the y value is calculating by this rule, which is just x. So if that is the case, then actually to compute the limit of the function at 1 from the left side is actually equal to computing the limit of which rule? Whenever we go closer and closer to 1 from the left side, this is the rule, right? So we just need to find the limit of x when x gets closer and closer to 1 from the left side. Wow, so if this is the case, you can see here this x is just a polynomial function, and we know how to find the limit of the polynomial function. We can just use the direct substitution property, or you don't need to even think about that. When x gets closer and closer to 1 from the left side, x will be, it's also approached to the same number, right? So if that is the case, or by the substitution property, we just replace x by 1, and then if that is the case, 1 is the left side limit of the function at 1. So similarly, if we need to find out what is the next problem we need to find the limit of this function when at 1 from the right side. So let's try to work on that one then. So our goal is to now find the limit of the function f of x, right, at 1 from the right side. So if that is the case, you need to see on the right side of 1 how the function is defined. Okay, so let's try to do that. So this is 1 over here, right? Let's just go closer and closer to 1 from the right side. But whenever I'm going closer and closer to 1 from the right side, you can see the function is defined by 2 minus x square, right? So for all of the, no matter how close you go, closer and closer to 1 from the right side, 2 minus x square will be the rule that will give you the y values, right? So that's how the y value behaves, based on that rule. So if that is the case, we can replace the function over here by that rule. So f of x can be replaced by 2 minus x square, and we just need to find the limit of that from the at 1 from the right side. Again, 2 minus x square then is just a polynomial function. So by using the direct substitution property, we can just replace x by 1. So 2 minus square of the 1. 1 square is 1. 2 minus 1 is just 1, right? So this is the right side limit. Yep, that's how we can find it. All right. So now let's try to see what is the limit of this function. That must be the straightforward work, right? So if you know the left side limit of the function, at 1 is 1. The right side limit of the function at 1 is the same thing. Then clearly that will just immediately conclude that limit of the function when we go closer and closer to 1, that must be equal to, or limit of the function at 1 is equal to, the 1, right over here. Why? The right side limit and left side limit at 1 is exactly equal to 1. So that's it. If these values were different over here, the right side limit is different with the left side limit, then the limit does not exist at 1. But on this case they are same, so the limit exists, and that is equal to 1. Okay. All right. So what is the next question we have? We need to find the value of the function at 1. That must be the most easy work, right? I hope, right? So exactly at 1, you can clearly see the value of the function is defined by 4, right? So if that is the case, then actually we can just write down f of 1 is equal to, what was the value of the function exactly at 1? Well, it's defined by 4, right? So that's what we have also given here. We summarize that information over here. So just 4 is the value of the function at 1. Done. So this is how we can find out. But we have a couple of other things we need to find it, but by using the same idea we can just move forward, right? We need to find the limit of the function and the left side limit of the function at 2. How can we do that? So let's try to do that one somewhere over here now. So limit, okay, of the function f of x at 2, is it from the left side? Oh, yep. Okay, so let's try to find the limit of the function from the left side. How can we do that? We just need to go closer and closer to 2, right? So we just need to go closer and closer to 2 from the left side. Whenever we go closer and closer to 2 from the left side, the rule here on the left side is defined by 2 minus x square. So that means then we just need to find the limit of 2 minus x square at 2 from the left side, but 2 minus x square is the polynomial, so we can again use the direct substitution property. So we get 2 minus, replace x by 2, so 2 square is equal to 2 minus 2 square, right? So then 2 minus 4, right? So this is then equal to negative 2. In the same way, let's try to find the limit of the function at 2 from the right side. I hope by at this stage you understand how this can be done. If you are not sure, then let's continue. Otherwise, can you try to find this limit of the function at 1 from the right side? How can we do that? We just need to go closer and closer to 2 from the right side. When we do that, this is the rule, right? And that has been defined over there. So if that is the case, what can we do? Just need to replace function by x minus 3, and let's go closer and closer to 2 from the right side. Again, this is polynomial, so 2 replace x by 2 by the direct substitution property, and then we just get that as negative 1. Interesting result here. You can see here the left side limit was negative 2, right side limit we just figured that out as negative 1. So if that is the case, then actually if we need to figure out, you can see here the limit of the function, then what can we say then? Actually on this particular case, then limit of the function at 2 does not exist. In an abbreviated form, if you want to write down DNE, that's fine, but the main thing is the limit does not exist, right? Why? Because the left side limit was negative 2, the right side limit is negative 1. They are not same, so when that happens at some particular location, at that location limit does not exist. Nice. So the final thing that we need to do is find the value of the function at 2, right? F of 2, that's what we need to find. So how do you find f of 2? We need to see exactly at 2 how the function is defined. Okay, you can see here, like here at 1 we knew exactly how the function is defined, but we don't have that type of direct information. But we do have, actually I can say, direct information in a sense that there is less than or equal to, right? When x is less than or equal to 2, then the function is defined by 2 minus x square. Or when we summarize the information, you can see here we have the bracket here, right? So that also gives us the perception that exactly at 2 the function is defined by this rule over here, 2 minus x square. So if that is the case, what can we do? Just use that as a rule to find the value of the function at 2, which means 2 minus, replace x by 2, so 2 minus square of the 2, then that is equal to 2 minus 4 is equal to negative 2. And this is how we can actually find and the value of the function at 2, and then some other limits that are given on this problem.